So we all right. So we have discussed the program till now that are actually followed some sort of pattern, okay, some sort of hierarchical pattern, you can say. So for example, we have seen the example of the stack frames. We have seen that main function will be the caller function for, let's say, square function, something like that, right? And then it may be possible that main is also calling some sort of printf function. Even square is calling printf function, something like that we have seen. Okay, we have also seen the notion of called function and caller function, right? So in this case, if we write or if we call square from inside the main function, then we will say this is the boss function or this is the caller function, and square is the called function or worker function. Okay. Similarly, you can call as many as functions from or within one function. So this is what we have seen till now. This type of programming is very common, but in this, generally we will not call the function in itself. So in square we will not call square function itself. In main we will not call again the main function, something like that, right? So till now what we have seen is one function is calling other function, and it is actually not calling itself in any way. Okay, so this is what we have seen. This is called hierarchical pattern. Today we will have a look at recursion. Now what do you mean by recursion? A recursive function is a function that calls itself, okay, either directly or indirectly. Okay, so if we say, okay, let's say this is the main function call, let's say, square function, and if suppose square function will call square function itself, within the square function we will again call square function. This is called recursion. Okay, or maybe in the square function we will call, say, some xyz function, and in this xyz function it is actually calling the square function. So this is also recursion. So a recursive function is a function that calls itself either directly or indirectly through another function. Okay, so this is called recursion. We are repeating or we are calling the same function again and again. Okay, and please keep a note of this. This is a very complex concept because our thinking is generally hierarchical, and it is very much easier to understand. The hierarchical thing is very easy to understand. Okay, we know that, okay, first main function will get called, then square function will get called, then maybe printf function will call, or then something else function will call. Okay, and it will return in the same manner. But if you think of recursive function, then you have to be very, very careful, because when one function is calling itself, it is kind of a loop, right? Inside one function we will call that function again, inside that function we will call that function again. So this is sort of a looping type of scenario, and it is a complex concept. And in detail you will always, I mean, this recursion will always come if you are a computer science student. Through the entire btech program you will somewhere come across with the recursion. Okay, so whether you can say a dsa course or a da course or os course or many other course, okay, everywhere you will see the concept of recursion. So this is really an important concept. So in this particular CP course, we will just, briefly have a look at what recursion is. And then in the later courses, you will dealt with it, in more detail. All right. So I hope the basic idea of recursion is clear to you. So we will say any function to be a recursive function if that function call itself either directly or indirectly through another function. Okay. Now let's say okay, so one more important thing I would like to mention here. This point is quite important. Recursive problem solving approach have a number of elements in common. So recursion is a problem solving approach. Okay, you will see in your DSA course there are many approaches to solve a problem. Okay, there are different design patterns to solve a problem, or there are many paradigm through which you can solve a problem, and recursion is one of that paradigm. Recursion is one of that approach through which you can solve many problems. Okay, so a recursive function is called to solve a problem. Okay, so please keep in mind that we are calling that function again in order to solve some problem. Okay, and why this point is important, let's see actually how recursion function work, and then this will be clear to you. Now, so how the function look like we are calling that function again and again inside the same function. So what actually that function is doing, is it just calling itself again and again or something else, right? So if it is just calling the same function again and again, then it is of no use. Then what that function is doing actually. Okay, so please remember, whenever you are came across with a recursive function, the recursive function actually knows only one thing. And what is that thing? How to solve simplest case of the problem. Okay, how to solve simplest case of the problem. This is the only thing the function knows. Okay, and this simplest case is known as base case. Are you following me? Yes.
Yes, ma'am.
Okay, so the function actually itself knows only how to solve the very simple problem or the base case of the problem. For rest of the solution, what it will do, it will call the same function again and again. So if the function is called with a base case or the simplest case, the function actually return a result. Okay, it will return a result. It will not call itself again. And here is the point where the recursion stops. If the function is called with a more complex problem, the function divide the problem into two conceptual pieces. A piece that the function knows how to do, and a piece that it does not know how to do. Okay, so when we look into the actual example, you will actually relate all this theory with that. So there are actually two possibilities. Either the function is called for the base case. If the function is called for the base case, it will not going to call the function itself. It will just return a result. Okay, return a result, and it will stop. If it is not the base case, so for any other case, okay, for any other case, and we are calling it as a complex case because this is not a simple case, this is some complex case. If it is a simple case, base case, then it will return the result, right? So for any other complex case, the function will call itself on a little smaller problem. Okay, now what do I mean by this? So these are the two conceptual part of the function. This is what is known to the function, and this is the case where it does not know what to do. So what it will do is it will call the function again, the same function again. Okay, so to make the recursion feasible, the later piece must resemble the original problem but be slightly simpler or smaller version. So suppose if we call the function for n is some number. Okay, we call the function for n. What actually the base case is? So base case could be when n equal to 0 or when n equal to 1. This is the result that you have to return. Okay, but what if n is some larger number? So this comes here. Okay, this is the second piece of the function where it does not know how to solve the complex problem. So what it will do, it will call the same function again with slightly smaller problem. Say it will call the function again with n minus 1. Okay, so what I will say, okay, I would like to solve the problem for n elements. If I know the solution for n minus 1 element, what I will do? I will do this small task. This simple task I can do. Are you following me here? So for example, let's say I would like to, some array of, I would like to have the sum of n elements in an array. Okay, so these are the n elements from 0 to something else. Okay, now what is the sum of this particular element? So suppose something is written, suppose 5 is written here. Okay, or let's say I would like to have a sum of n natural number. That is much more simple case. I want the sum of n natural numbers. Okay, 4, 5, so on, so forth, and n is given to me by the user. So what I will say, okay, let's have a look at the problem in this way. What is the sum of first natural number?
1.
1. Okay, so this will act as a base case. So we will say when n equal to 1, when n equal to 1, please return 1. Please return 1. But for all other cases, what I will do, I will call the function again, the function which will actually calculate the sum.
Ma'am, you are not audible.
Hello everyone. Sorry, I lost connection. So till what point, till what point you got the things?
Starting for sum of natural number.
All right. So sum of natural number is clear how it will work?
No, ma'am.
No, ma'am.
Okay, okay, okay.
No मैम उसकी just start हुआ था.
Yes, ma'am. You just started, ma'am.
Okay, okay, okay. Sorry. All right. So okay, so let me just explain again. So suppose you have to find the sum of n natural numbers. Okay, so the sum of n natural number will 1, 2, 3, 4, and so on and so forth, right, till n. And suppose n will be taken from the user. Okay, now what is the base case? I think this is also covered. What is the base case when n equal to
1.
1? This is the base case. So when n equal to 1, what the function has to return? The function has to return 1. So this is the only thing which is known to the function. Rest everything, you have to call that function again. Okay, so let's call this function as some natural, something like that, some natural function. So what this function will do, for the base case it can solve the problem, but for all the other cases, it will actually solve a smaller problem. It will call the same function again and again to solve the smaller problem, right? So for example, if I will say, okay, I have to find the sum of n natural number. If somebody tell me that what is the sum of n minus 1 natural number, then what I will do, I will take that sum. Okay, so somebody will tell me this part. What I will do, I will just add n to it and return to the user. Agreed? Yes or no?
Yes ma'am.
Okay, so what we will do, we will call the function, this square natural function for this number. Please give me the result of this. Then what happened? N minus 1 will say, okay, please give me the sum of n minus 2, first n minus 2 natural number. If you give me this sum, what I will do, I will add n minus 1 to it and then return to the original problem. Okay, so n, when we call it for n, it will call for n minus 1. N minus 1 will say, please give me this. N minus 2 will say, please give me the result for n minus 3. Right? So on and so forth. So we will keep moving it till we hit the base case. Because the function only knows how to solve the base case. So the base case will say, okay, the answer is 1. Then what it will do? It will say, okay, I will just return. So it will return this to this. Then this will actually do the calculation and return again to the original problem, the problem that called this particular n minus 3. The return from here, the result from here will be returned to n minus 1, and finally the result will be returned to the original problem. So this is our original problem. Okay, and what in recursion, what we are doing, we are calling the function again and again to solve a smaller problem, because it is known that if the smaller problem is solved, then the larger problem will automatically get solved. Are you following me here? Yes.
Ma'am.
Okay,
Yes,
so
ma'am.
the new problem should also look similar to the original problem. So the original problem is finding the sum of n natural number. The new problem is finding the sum of n minus 1 natural number. Okay, so the problem is actually same to the original problem. The only difference is, in the original problem the size is larger, and in the new fresh problem that has been called by the original problem, the size is little smaller. Okay, and what happened in the memory, actually in memory, what happened, every time the fresh copy of this function will get created with the new parameter. So here some natural will get created with n, then some natural will get created for n minus 1, then for n minus 2, so on so forth, till we hit the base case. Okay, and this point you have to keep in mind, that the return keyword should be there in the sum of natural number. In any recursive program there must be a return keyword. And why it is required to have a return keyword? Otherwise, if there is no return, then it is sort of an infinite loop of recursions. Okay, the function will never terminate. So actually this base case which has return is the terminating condition for the recursive call. Okay, so each time we call the problem again for some smaller size, this is called a recursive call. This is called a recursive call or a recursion step. Okay, and this is how it will work. So yes, so to make the recursion feasible, the later piece must be resemble to the original problem. This is the first point. It should resemble to the original problem. And second point is, it should be slightly simpler than the original problem. Okay, so our resemblance is, we are finding the sum of again the natural numbers only, and we are calling it for n minus 1. Next time we will call it for n minus 2, then we will call it for n minus. So our problem size is actually decreasing. Okay, so these are the two properties which should be true for any recursive call. Are you following me here? Any question till here? Yes, no?
मैम रिटर्न में क्या लिखेंगे?
So in return, you have to return what is the answer of the base case. Okay, this is the part the function knows actually. This is the only part which is known by the function.
मैं फैक्टोरियल में भी यूज कर सकते हैं ना हम इसको फैक्टोरियल कैलकुलेशन में.
Yes, definitely we can use it. We will see in today's class the example on factorial. Okay.
Okay.
Okay, but the overall idea of recursion is clear. Okay, so if I want to summarize again, so you have to remember 2-3 important things. First thing is recursion. Recursive function is a function which call itself either directly or indirectly through another function. This is what recursion is. Recursive function is. In a recursive function, you have to keep in mind that the base case should be mentioned, which will actually return the result. Whenever you are calling a recursive function, please make sure that the recursive call is same as the original problem, but on a slightly smaller version of the problem. Then only it will make sense. Then only it will help you to solve any particular piece of problem. Okay, and where this recursion terminate, each time when the function call itself with a slightly simpler version of the original problem, this sequence of smaller problem must eventually converge on the base case. Right? Every time we are calling or we are reducing the size of the problem, and eventually it will happen that it will reach to the base case. And it is mandatory to mention the result of the base case or to return the result from the base case. Okay, so when the function recognizes the base case, it will return the result to the previous copy of the function, and a sequence of return will ensues all the way up to the line until the original call of the function will hit. Okay, so I think there is one diagram also. Let me show you that diagram. Yes, this is the diagram. So, some of you are telling me that, we can do it on the factorial also. So this is how it will work. So first, let me tell you what factorial is. Okay. All right. So, okay. So what is actually factorial? If we say 5 factorial, what do you mean by 5 factorial? You have to multiply 5 till, this is what 5 factorial is, right? You have to keep multiplying all the natural numbers till 1, starting from the number for which you have to find the factorial. So 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Okay. What is the normal way to solve this problem? This is the normal way. If I tell you that please solve this problem, what you will do? You will say, okay, let me just use a for loop. What that for loop will do, that for loop will actually start multiplying the number. Okay, and we will decrement the counter, and each time the counter will be multiplied to the number. Okay, and this is how you will follow the for loop. This will work perfectly fine. So factorial, you have to initialize it with 1. You cannot initialize it with 0 for obvious reason. It is a multiplication operation. Then we will have our for loop and we will say, okay, counter equal to number. This is the number which is given by the user as an input. And we will keep multiplying the counter and, store the result in the factorial. Okay, so the counter starts from the number. Suppose the number is 5. So first, 1 into 5 will happen. Then 4, because counter is decrement by 1, then 3, then 2, then 1. Okay, and this will result into 5 factorial. This is how a simple program, non-recursive version of the program will work. And I hope this is very clear to you. Okay, this is very clear to everyone. Now, what is the result of 0 factorial? It is 1. What is the result of 1 factorial? It is also 1. Okay, and these cases will also get handled by this for program. So no issues in that. This is a non-recursive version. Now let's see how we can make a recursive program out of this. Okay, so first of all, you have to make sure that you have to make the you have to define the problem, okay, in a recursive way. So I will say, okay, you want to find the factorial of 5. All right, please give me the factorial of 4. I will multiply 5 to it and give you the result. Okay, when I say, okay, factorial 4 will say, please give me the result of factorial 3. I will multiply it with 4 and then return the result. Okay, 3 will say the same thing. 2 will say the same thing. When we reach to 1 factorial, okay, what we can do, either we can consider this as a base case. Okay, what 1 factorial will return?
1.
1 factorial will return 1. Okay, so this 1 factorial will get replaced by 1 because 1 is returned, and this entire thing will become 2, right? And 2 factorial is actually 2, so this is written here, and this will get replaced by 2. Then 3 into 2 will happen. 3 into 2 is 6. Okay, so 3 factorial will be replaced by 6. And this is how returning will be possible. Okay, then 4 into 64 is 4 into 6. 4 into 6 is 24, and it will get pasted here. And then we will have 5 into 2, 24, and this will get returned and it will become 120. So are you getting my point? First, we will do a recursive call where we call the same factorial function for smaller problem. Okay, in the first recursive call, we will call for 4. Then we will call for 3. Then we will call for 2. Then we will call it for 1. And when we reach 1, it is the base case. And from here, the returning will start. Okay, and hence we get the solution to the original problem. This is how recursion will work. Okay, so what is n factorial? N factorial is n into n minus 1 factorial. This is what we have to write inside the function. Okay, so now let's see the program actually. Then we will again come to this. Okay, so this is something that I draw. Okay, and this is how it will get returned. So the caller works in this way and the returning works in this opposite manner. Okay. Yes, so this is the program. Here what we are doing is we are calling the factorial function recursively, and our aim is to find the factorial of numbers from 0 to 21. Okay, so this is a non-recursive call. We want factorial of all the numbers, and in each call we are calling our factorial function. This is a simple iterative program. Okay, non-recursive program are when you make a program using for loop, it is called iterative program, iterative version. Okay, so we are calling this. Okay, now what happens? So for the first time when the loop will get called, anything you want to tell? I heard a noise actually. Any question?
Someone has raised hand.
Okay, so please ask actually. Unmute yourself and ask the question actually. I cannot see the screen or the chat box. All right, so whenever required, you can unmute and you can speak out, okay? Right. So yes, what we have to do in this particular function, we have to find the factorial of all the numbers from 0 to 21. So we will have a loop which will start from 1. We will increment I by 1 and the loop will execute till 21. And each time what we are doing is we are calling this factorial function. Okay. Now why we are using long int and everything, that I will discuss a little later. First, let me show you how this recursive function will work. Okay. All right. Now in this recursive function, so this is the factorial function. This is the actual definition of the factorial function. This is a recursive definition. Okay. Why? Because in this function, I am calling factorial again. Again, I am calling the same function, and therefore it is called a recursive definition of the factorial function. Okay. So now first, what you have to do, first you have to define the base case. This is also very important. You cannot write this thing in the beginning. In the very beginning of any recursive function definition, you have to mention the base case. If the number is less than equal to 1, then the function has to return 1. Okay, so if the number is 0 or the number is 1, what you have to return? You have to return 1. Otherwise, what you have to return is this: number into factorial of number minus 1. Okay, so if the value of number is 5, just for example, okay, if the value of number is 5, then actually this definition is writing something like this: factorial of 4. Just give me factorial of 4. I will multiply this, whatever returned by this function call, I will multiply it by 5 and return the actual result. Okay, so in the memory, what happened? This factorial 5 is called. This factorial 5 will actually call factorial 4. Okay, and what is written here? 5 into whatever result come from here, whatever result come from factorial 4. Factorial 4 says, okay, I will do 4 into, I will call factorial 3. Same for factorial 2. Factorial 2 says I will multiply 2 with whatever result returned from factorial 1. When we call the function for factorial 1, what will happen? The number is less than equal to 1. This condition become true and I will return 1. I will not go again to the recursive function call. And here is the point where this recursion terminates. Okay, so this function 1, factorial 1 call will return 1. Okay, and here it will become 1. 2 into 1 will become 2. So this particular version, this particular copy of the function will return number into factorial of number. So 2 into factorial of 1, that is 2. It will return 2. Okay, 2 will get returned here. Okay, and the existence of this function call will disappear in the memory. Similarly, what it will do 3 into 6. This version will do 3 into 6, and that 6 will be returned, and then there is no existence of this, so on so forth. Okay, and this is how it will work. And finally, this factorial has been called from the main function. Okay, so we will return 120 to the main function. Now, is it clear? The concept of recursive function call is clear to you? Yes or no? Yes?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
in recursive function call, please note that you have to call the same function again and again on the smaller version of the program. This is one thing. And the second thing is, in the beginning of the function, you have to mention the base case. What happens if you switch these two things? what happen if you switch this thing? We will say okay, if में हम लोग रखेंगे this particular line, and in else we will write the base case. What will happen in that case? What will happen in that case? Any idea?
मैम 0 आ जाएगा.
Yes, any idea? So if I say okay, if number is less than 1, return 1, this particular block I will place afterwards. Okay, and this return number into this line I will place in the very beginning. What will happen?
1.
It'll loop infinitely, won't it?
Yes, it will loop infinitely. Why it will loop infinitely? Because there is nothing to stop this recursion. Every time when it will just say okay, return for a number less than the current number. Okay, and this is sort of an infinite loop of recursion. Okay, so please keep in mind to define the base case in the beginning. Okay, after that you have to mention the recursive call. This is an important thing, and generally people, the programmer actually miss this part, and because of that there are segmentation fault and memory out of stack, something like that error. Okay, because there are infinitely many recursive call which will actually make the memory out of stack. Okay, now let's discuss this particular problem. Now the factorial. Okay, so let me just show you the output first. The output is this is the output. Okay, 0 factorial 1, so on and so forth. Okay, 21 factorial is this. Now this actually factorial problem, the output will exponentially increased. Okay, मतलब बहुत तेजी से it will actually increase. The number will be too large, and therefore we have to make it of long int type. Okay, we have to make it long int type. So I hope somewhere it is mentioned in the slides. If not, yes. So this uses recursion to calculate and print the factorial, the integer from 0 to 10 or 0 to something. But the type you have to keep is unsigned long int. Why you have to keep it unsigned long int? Because the factorial is increased very rapidly. Actually the number will get increased. Okay, so therefore you have to use unsigned long int. Even if you keep it unsigned long int, you cannot calculate factorial beyond 21 factorial. The number is very high. Okay, so the recursive factorial function first test whether a terminating condition is true, that is the number is less than equal to 1. So this is the first thing the factorial function is do. If this is true, the function is returned from there. If it is not true, another recursive call has been made, and we have used this LLU, long unsigned int, to print this values, because the factorial function produces large values so quickly. Okay, this is called exponential thing, exponential increase. Okay, that even an unsigned long int does not help us to print factorial of a larger number. Okay, so I think we cannot go beyond 21 factorial. C++ can handle, but that is out of the scope of this course right now. So a common error which has been made is forgetting the value to return from the recursive call. Okay, and this will lead into the infinite loop. Now there is one more programming error. Either we forget to mention the base case, or we forget to write the recursive step incorrectly. Instead of calling it for smaller problem, we are calling it for larger problem. Then also the same thing will happen. It will go into the infinite loop because it will never met with the base case. Okay, so you have to keep in mind both of these things. Okay, and recursive call are generally memory exhaustive calls. Okay, so you have to make sure that it will not go into the infinite loop. So any question now? Any question in this program, in this recursion, in this recursive version of the program? Anything? Okay, so now let me tell you one more example of recursion on Fibonacci series. Okay, so everything is clear. Any question? I hope not. Yes? One or
No,
two
ma'am.
students speak up.
No, ma'am.
Okay.
No, ma'am.
So see, all the programs that we have made iteratively can be done by recursion, and all the recursive programs can be done through iterative version also, right? So it's the choice of the programmer what to use. I will tell you the pros and cons of both type of programming paradigm. Okay. So first, let's discuss this Fibonacci series, and we will make a recursive Fibonacci series in for this particular problem, and then we will have a look at both the versions of the programming paradigm. So what do you mean by Fibonacci series? Fibonacci series begins with 0 and 1, and it has the property that each subsequent Fibonacci number is the sum of previous two Fibonacci number. Okay, so it will actually start with these two numbers. So the sum of 0 and 1 is 1. So it will become next Fibonacci number. Then the sum of 1 and 1 is 2. It will become next Fibonacci number. Then the sum of 1 and 2 is 3. It will become next Fibonacci number. 2 plus 3, 5. 3 plus 5, 8. So on and so forth. Okay. This is called Fibonacci series. This is also a very, very famous series. It actually, people, mathematician relate this series with the nature also. And, the ratio of two successive Fibonacci number, the average of the ratio of two successive Fibonacci number is 1.618. And this is actually the golden number in computer science. This is the golden number. This is treated as a golden number. So golden number is actually the ratio of successive Fibonacci numbers. Okay. And this number is repeatedly occur in nature at many places. Mathematician found that this number or this ratio will occur. Therefore, it is called a golden ratio or golden mean. Okay. And architects design their windows, rooms, and buildings whose length and width are in this ratio. Okay, so this has been treated as very good number and something like that. Even the postcards are often designed in this ratio. Okay. So anyways, like, this is just an extra knowledge I'm giving you. But Fibonacci number for us as a programmer is what we have to do. We have to start with 0 and 1, and then to get the next number, what you have to do, you have to just take the sum of previous two Fibonacci number. Okay. And this is how we will make a Fibonacci series. So what will be our base case? If you want to make a recursive function, first you have to think of the base case. What will be our base case?
0 and 1.
0 and 1.
Fibonacci number, Fibonacci for 0 is 0. If somebody will say, okay, please find me the Fibonacci series till 0. So the answer is 0 because it is only one number. If somebody will say, find me the Fibonacci series of 1, it is again 1. Okay, so these two will become base case, 0 and 1. Okay, and what is the general recursive call that we have to make? We have to take n, and what we have to take, Fibonacci of n will become the sum of Fibonacci of n minus 1 and n minus 2. Okay, the previous two numbers. Clear? We have to find the Fibonacci for n minus 1. We have to find the Fibonacci for n minus 2, and then we have to add them. Okay. So we have to actually calculate nth Fibonacci number recursively using the Fibonacci itself. And this is how we can do it. Okay, and this also we will take long end because this also increase exponentially. Okay, so these are few problems in computer science whose complexity is exponential, and you will learn more about it in DSA course, right? So this is the simple program that will actually give you the Fibonacci number. So the return type of this Fibonacci function is long end, and we will actually pass a simple int, unsigned int, positive number. Therefore, we are using unsigned int n. This is the function prototype. Okay, this is the return type of the function, and this is the type of the parameter or the argument that will taken by the function. Okay, now what we are doing is this: we are we are making a variable result where the number will be stored, and then we are taking a number from the user. Okay, so this number will be entered. Now we have to find, suppose, sixth Fibonacci number. Okay, so the sixth Fibonacci number will be the sum of fifth number and fourth number, right? So this is what number is. So user will get, say, 6. So we will say okay, so Fibonacci 6 means, the number which is there at the sixth position is actually the sum of the number which is there at the fifth position plus the number which is there at the fourth position. This is what this sum will actually give you the result. Okay, so we will take the number from the user and we will call our function. So this is a normal call. Okay, Fibonacci for the number we will call, and we will store in the result, and we will print the result that Fibonacci for this number is this. Now let's say how we have defined our Fibonacci number thing. So first we define the base case. If the n equal to, if somebody is asked us the 0th number or the nth number, 1th number, okay, the first number, then we will return n. Okay, and otherwise we will return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, so for 0 it will return 0, for 1 it will return 1, right, depending upon the value of integer. If somebody say 2, okay, so 2 actually at second position, so 0, 1 and then 2 at second position, it is the sum of first and second number, 0th or first number. Okay, so it is 1 written there, it will return 1. If we will say 3, then we will return 2, so on so forth. Okay, any question? This is a very simple program which is making
मैम,
use
if
of
केस में if
Yes,
केस में
sir.
0 equal to n क्यों यूज हुआ, n equal to 0 क्यों नहीं?
It is up to you. It is not a big deal. Okay, you can write n equal to 0. There is no issue in this. In comparator operator, you can use this variable at any place, but if you are doing assignment operator, then it is compulsory to use to keep variable at the left hand side. Okay, since this is a comparison operator, it does not matter. So let me show you through diagram how these functions get called. Yeah, so this is how it will call. If we call for Fibonacci of 3, okay, then the program will say return Fibonacci of 2 plus Fibonacci of 1. Then Fibonacci of 2 will be solved. It will say, okay, Fibonacci of 1, Fibonacci of 2. It will return this. Fibonacci of 1 will return 1. So this entire thing will get replaced by 1. Fibonacci of 0 will return 0. So this entire thing will be replaced by 0. And this entire thing will return 1 plus 0, that is 1. Okay, so Fibonacci of 2 is replaced by 1. Similarly here, Fibonacci of 1 will return 1. So this thing will replace by 1. And 1 plus 1 will become 2. So Fibonacci of 3 will become 2. Okay, so 0, 1, 1, 2. This is how it will get called. Okay. Is it clear? Yes, no, any question?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes,
So,
ma'am.
it is really an interesting thing to
Thank you,
have
ma'am.
yeah. And one more thing I would like to mention here is this. order is not important. If you think it will calculate, the computer will calculate in this order, that is wrong. Okay, so there are many optimizers which work behind the compiler. Okay, so order doesn't matter. It may be happen that Fibonacci 1 will be calculated first and then Fibonacci 2 will be calculated, or the reverse, depending upon the optimization of the compiler. ठीक है, even in one system it may be possible that every time something else is happening, depending upon what are the things which are available in the memory. Depending upon that, compiler will execute the things. Okay, so the order doesn't matter because at the end result will be same. Okay, so don't think that it will happen from left to right or right to left, something like that. Order does not important. What is the time?
12:54.
12:55.
So I think,
5:55.
yes, so just I will give you one important. So exponential complexity, I have told you have to use long int in this. Okay, yes, so this is one thing I would like to mention quickly: recursion versus iteration. Okay, so both are important. Now let me just compare these two things very quickly. Both iteration and recursion are based on control structures. Okay, in iteration we use repetitive structure, that is loop, right? Loops are used in iteration. Okay, and recursion we use selection structure. Selection means the if else thing, only if else we are using, whereas in iteration we are using loop things. Okay, and how we will do a looping sort of a thing in recursion? By calling the function itself again and again. Okay, so actually both iteration and recursion involve repetition. The only difference is iteration explicitly use the repetitive structure, that is loops, whereas recursion achieve this repetition through repetitive function calls. Are you follow me here?
Yes, ma'am.
In both the cases repetition is required. So iteration or iterative version of the function is one which uses loop, and recursive version is one which uses if else statement, but it achieve repetition through repetitive function call to itself. Okay, and both involve in the termination test. The loop terminate when the condition fails, and this recursion terminates when the base case is met or the base case is recognized. So this is how both terminate. Iteration with counter control repetition and recursion each gradually approach to termination. So in iteration, we modify the counter variable, okay, so that it will converge to the condition where the counter variable condition will get false. Whereas in case of recursion, we will keep on producing simpler version of the original problem until the base case is reached. Okay, so both are having repetition in different ways, both are having termination condition, and both are having controlling structure. One work on the looping variable and one work with by calling the same function for smaller problem. Okay, so this is how these two are related. So yes, and in both of the cases it may happen that they go into the infinite loop. If you wrongly place the condition for loop, it is called infinite loop. If you wrongly place the function base case in the recursion, it is called infinite recursive state. Okay, so both have pros and cons. So can I continue for one more minute? Only these two slides are remaining.
Yes.
Yes, ma'am.
All right.
Yes, ma'am.
Yes, ma'am.
Recursion has many negatives also, many negative points also. What are the negative points? It will again have the function call again and again. So if you remember, in the memory it is too much overhead to make a function call. It is quite easy to change the value of one variable, but to make the entire stack frame for different function, this is too much overhead. Okay, so recursion is very expensive for both processor and for the memory also. In this sense, this is the negative point of recursion. Okay, this is very expensive in processing time and memory space. Why? Because it is calling the function again and again, and there is a lot of work that the computer has to do to make the state frame of the function. Okay, now this is the negative point. And each recursive call causes another copy of the function to be created, and this consumes lots and lots of memory. Generally, iteration is little less overhead because it does not require any other function call, just change in the one memory location. Okay, then why we are using recursion? So one important point to use recursion is this: the programming is very easy. I mean, you can see how easy you can make the program of the recursion. It is just a 2-line program. Just define the base case and call the function again. So it is very simple for the programmer to make such programs. Okay, and that is why people use recursion to solve very complex problems. Okay, so this is all about recursion and iteration. Okay, so